Well, I'd like to say that this is going to be a little video, but yeah. Sometimes it actually takes time. I will certainly try to keep this under 20 minutes, but there's a few things that I want to present. First things first, here's a list. If you want to solve these equations by factoring, then you move through these 3 steps roughly. Move things around until you have some polynomial equaling 0. Remember that you want to expand everything if it's kind of contracted and one of the examples is. So be sure to expand. And combine like terms. Factor the polynomial, then set each factor to 0 and solve. You may end up with repeated solutions, and I'll show you how to deal with those. Alright, well, I don't like to just kind of jump into this willy-nilly. So why does it work? Alright, well, let's assume this. If I have 2 factors and they're multiplying, and that gives me 0, then what can you say about one of the factors? This is not an assumption, by the way. This is a provable statement. So a and b are real numbers. And the question is, if a times b equals 0, does that force one of them to be something? Well, from the gut, it kind of looks like it would force one to be 0. So let's try it. But this way we're going to assume the opposite. So let's assume, this is, by the way, called proof by contradiction. Assuming a is not 0, okay? Because if it is 0, we can't do the thing that I'm about to do. So we have this statement, a times b is equal to 0. Because a is not 0, I can divide both sides by a. A divided by a, no matter what it is going to be 1, leaving us with b. And 0 divided by any non-zero number is 0. So if a is not 0, then this condition forces b to be 0. Likewise, replace a with b and you have the other side of it. Replace a with b to get other half. From what I've seen of professional mathematicians, unless it's a very, very formal paper on it, there's something they use called without loss of generality. Sometimes W log is the way I've seen it. But basically what it's saying is, wash, rinse, repeat, just change the letter. The same exact thing works. So that's what I'm saying here is just replace a with b, walk through the same exact process, and you'll show that a can't be 0, or a is forced to be 0. So you can extend this, by the way. So you can extend this to 3 or 4 or however many factors you want. Point being is that if you have 2 numbers that are multiplying and they equal 0, then one of them must have been 0 to start with. That's what we're going to use to do number 3 here, which is to set each factor equal to 0 and solve. Here we go. So here are some examples. I'm not going to go through the factoring necessarily, at least not by detail. I've got other videos that walk through examples very similar to these in very, very detailed fashion. So I'm not going to spend too much time on that aspect. First thing we want to do, though, is we want to get everything on one side. It doesn't matter which side, just get everything on one side. How you do this is entirely up to you. The decision that I make is I check for the leading coefficient. I want to make that positive because it's just going to make my life easier. And I'm inherently lazy. Don't want to spend a lot of time doing extra crap. All right, so we are satisfied with this first piece because we have some polynomial is equal to 0. Good. Now step 2, we factor. That's it. We factor it out. So I need 2 numbers that multiply to 12 that add to 7. That's 3 and 4, and so this is going to be x plus 3 and x plus 4. Wait, I got x plus 4 times x plus 3. Yeah, it's the same thing. It's okay. So now I have 2 numbers, and this is the part that sometimes is difficult for people to see. This is taking the place of A, and this is taking the place of B. So I have some number times another number gives me 0. One of those numbers must have been 0. Which one? Oh. So we try both. So we're going to say that x plus 3 is equal to 0, or x plus 4 is equal to 0. I would not get into the habit of just changing out the signs. That seems like a really bad idea to me, but some people do it. I don't know why. If I subtract 3 from both sides, then that gives me x is equal to negative 3. Or if I subtract 4 from both sides, that gives me x is equal to negative 4. So this is an or statement, by the way, because it's not a forced and. Either one of these could have been 0, and it would force the thing to be equal to 0. So there's our solution. X is equal, whoops, let's get rid of that comma there since it doesn't belong right there. Negative 3, negative 4. But I have a different order. That's fine. It's a set. Order is irrelevant. All right, here we go. Next one. Same exact idea. Step 1, get everything over to one side. I'm going to choose to move the 15x so that the 3x squared stays positive. Now, I could have started with dividing by 3, but yeah. By the way, this is a danger zone. Don't divide by x. Don't do that. It's bad. You don't know what you're dividing by. So you could be dividing by 0. And that's not, you can't have that. It's bad. Things blow up, black holes are made. Anywho, so we're doing that. We get 0 is equal to 3x squared minus 15x. To make my life a little simpler, I am going to choose, because I see that 3 and 15 is a common factor that's numerical, not a variable, I'm going to divide both sides by 3. That's going to give me 0 is equal to x squared minus 5x. So now I have a polynomial is equal to 0. I'm going to go ahead and factor this out. 0 is equal to, x is a common factor, x minus 5 is left. So I'm done. The x minus 5 is already a linear factor. Now just set each of those equal to 0. So x is equal to 0, or x minus 5 is equal to 0. Well, x is already equal to 0, so that's done. So if I add 5 to both sides, x is equal to 5. So my two answers, x is equal to 0 or 5. Do I have to put them in the little squiggly things? No, you do not have to. It's not a most instructors don't care. It's a set. I mean, the answer is technically a set, so you should. But at this point, we're just, can you do it? If you do, great, awesome. If your instructor is the one that does it, then listen, accept it, move on. In this next example, I'm going to show you that you don't have to go through just the raw steps. So we start by dividing by 4. That gives me x squared is equal to 4, the other 4, and that's a squared. And now I have to get everything on one side. So I'm going to go ahead and subtract 4 from both sides, giving me x squared minus 4 is equal to 0. If you don't recognize this, this is a difference of squares. And it factors out in a very specific way each and every time. It factors out as the sum and difference. So this is going to be the sum and difference of roots. And that's it. And you can check that by remultiplying it in. We got that. So now we set each one of those factors equal to 0. Are you noticing a trend? And then solve. So from here, x is equal to negative 2 or 2. And there you go. That's it. Finally, we have this monstrosity. This kind of goes into that little aside that I mentioned after step 1. I said, oh, by the way, some polynomial. Make sure you expand everything out. Expand this out to start with, just to make your life a little easier. 3x squared plus 9x is equal to 4x minus 2. Move everything to one side. So I'm going to subtract 4x. And I'm also at the same time going to add 2 to both sides. What that's going to do is it's going to eliminate that whole right side, leaving me with 0. On the left side here, we're going to have 3x squared. We combine like terms, and so we have 9 minus 4 is a positive 5x. And then we have this plus 2. Now it's going to hurt because now we don't have a leading coefficient of 1. Oh, the pain. I do this a specific way. If you need some help on this, there's multiple ways to do it. I tend to do it this way because it's fairly easy to me. And so I just need to find two things that multiply together to give me 6, but add to 5. So what I'm doing here is I'm splitting each one of these up and just factoring those out so that I can find the exact pairing. What I want to do is I want to pair the 3 with the 1, so those two have to multiply, and then the 1 and the 2 have to multiply. When they do, I get 3 plus 2, and that's 5. So that's my pairings. The 1 and the 3 will come out to the front of each factor, and the 1 and the 2 will go to the back. Where they go is important. If they're multiplying together, they cannot be in the same factor. So I'm going to put an x here and a 3x here. If the sign is negative, by the way, if the second sign is negative, it actually complicates this whole disaster. So if you're uncomfortable with this method, don't use it. Use something else. The 1 had to combine with the 2, so the 2 has to go over here. And I know both signs are the same, and then they must be positive because I get a positive answer when I combine. So, plus 1. And now I can just kind of re-expand it and check. So this is going to be 3, this is going to be 2. I add together to get 5. That's 2, that's 3. Yeah, it works. So, set each one equal to 0. Or 3x plus 2 equals 0. Subtract 1 from both sides, x equals negative 1. Or, now this is a two-stepper, so don't try to do it in your head if you're not comfortable with it, but subtract 2 from both sides. It's going to give us 3x is equal to negative 2. And then I divide both sides by 3. That's going to give us x is equal to negative 2/3. So my two solutions here, x is equal to the set negative 1, negative 2/3. And again, it doesn't matter the order inside there. That's it. That's how you solve these. It changes somewhat depending, but as you can see, there's not one way to do it. But the general idea is get the polynomial onto one side, factor it out completely, set each factor equal to 0. If you have a lead, like in the third example here, I had a leading coefficient of 4. Even if you were to factor that out as greatest common factor, you can divide that through and just kind of forget about it. Forget about it. Notice how the 4 just kind of disappeared. I could have put it through the difference of squares, but you would have found out it wouldn't have mattered. It would have still disappeared. So I prefer to kind of shrink them down first, and then go through it. All right. Well, I hope this helps because it sometimes is a little bit pain in the butt. Take care.